The Big Bang. Birth of the universe. Have you ever looked up at the night sky and wondered, where did it all begin? The stars, the galaxies, the planets, and even time itself. How did it all come to be? Today, we're going to take a journey back in time, all the way back, 13.8 billion years ago, to the greatest cosmic event ever imagined. The Big Bang. This isn't just a story about explosions. It's the origin story of everything we know, and everything we don't. What is the Big Bang? Let's get something straight. The Big Bang wasn't an explosion in space. It was an explosion of space. It wasn't a fireball expanding into emptiness. It was space itself expanding, carrying galaxies, stars, and time along with it. According to modern cosmology, the Big Bang theory is the most widely accepted explanation for the origin of the universe. It's supported by decades of scientific evidence. But how do we know any of this? Let's rewind the cosmic clock. Before the Big Bang, time and space as we know them didn't exist. Imagine a point, infinitely small, infinitely dense, and infinitely hot, containing everything. All the matter, energy, and even the laws of physics, compressed into a single point. This state is known as a singularity. We don't fully understand what it was, because our current physics, especially Einstein's general relativity, breaks down at this point. But we do know what happened right after. The first moments. At the moment of the Big Bang, this singularity began to expand. Not explode, expand. In less than a trillionth of a second, the universe went through a phase called cosmic inflation. During this phase, the universe expanded faster than the speed of light. Yes, faster than light. This doesn't break any rules because it was space itself stretching, not objects moving through space. This sudden expansion smoothed out the universe and gave it the structure we see today. The early universe. After inflation, the universe was a hot, dense soup of particles, protons, neutrons, electrons, and a lot of radiation. It was too hot for atoms to form. Light couldn't travel freely. Everything was just a glowing fog of energy and matter. But as time passed, the universe cooled. Within a few minutes, nuclear fusion occurred, forming the first atomic nuclei, mostly hydrogen and helium. This is called Big Bang nucleosynthesis. It wasn't until 380,000 years later that the universe cooled enough for electrons to join these nuclei, forming the first neutral atoms. This event is called recombination. And at that moment, the fog cleared. Light was finally free to travel. That ancient light is still around today. We call it the cosmic microwave background, or CMB. The cosmic microwave background. The CMB is one of the most important pieces of evidence for the Big Bang. It's the afterglow of creation, the earliest light we can see. Discovered in 1965 by accident, this faint microwave radiation is spread throughout the universe. It's like a baby picture of the cosmos, showing what the universe looked like just a few 100,000 years after its birth. And it's nearly the same in every direction. That's no coincidence. It's proof that the universe began from a common origin. Formation of galaxies and stars. After recombination, the universe entered a period called the Cosmic Dark Ages. It was filled with neutral gas, but there were no stars. No light. Over hundreds of millions of years, gravity began to pull matter together. The densest regions collapsed to form the first stars, igniting fusion and lighting up the darkness. These first stars formed galaxies. And over billions of years, galaxies merged, evolved, and gave birth to more stars, planets, and eventually, us. Expanding universe. Now, let's jump to the 20th century. In 1929, American astronomer Edwin Hubble made a stunning discovery. Distant galaxies were moving away from us. And the farther they were, the faster they moved. This meant the universe was expanding. And if it's expanding now, that must mean it was smaller in the past. Much smaller. This observation was one of the key moments that gave birth to the Big Bang theory. And here's the kicker. The expansion hasn't stopped. Even today, the universe is stretching, and galaxies continue to drift apart. Dark energy and the accelerating universe. But here's something even more mysterious. In the late 1990s, scientists found that the universe isn't just expanding. It's expanding faster and faster. This was unexpected. Gravity should slow things down, right? But something was pushing the universe apart. That something is called dark energy, a force that we still don't fully understand. It makes up about 70% of the universe, and it's responsible for the accelerating expansion. Dark energy remains one of the greatest unsolved mysteries in science. What came before the Big Bang? So, what came before the Big Bang? Here's the truth. We don't know. Some theories suggest the universe is part of a multiverse, one of many universes constantly being born and dying. Others propose a cyclic universe, where big bangs and big crunches occur over and over in an eternal cycle. And some physicists believe asking, what came before, doesn't even make sense, because time itself began with the Big Bang. For now, the truth remains hidden beyond the reach of our instruments and our understanding. Why it matters. So why should we care about the Big Bang? Because it's not just a theory, it's our story. Everything you see, every tree, every star, every breath you take, is part of this grand unfolding of the cosmos. The atoms in your body were forged in the hearts of ancient stars. Those stars were formed from gas created after the Big Bang. That means you are made of stardust, a direct child of the universe. The Big Bang isn't just a beginning. It's a bridge between physics and philosophy, science and wonder. Where are we going? As we look forward, scientists are asking, what is the future of the universe? Will it expand forever, becoming colder and emptier? Will dark energy tear everything apart in a big rip? Or could gravity eventually halt the expansion, leading to a big crunch? Right now, the evidence points toward an eternal expansion. A cold, dark, and lonely future. But the universe has surprised us before. It might do it again. The Big Bang is more than just a scientific idea. It's a breathtaking insight into the origin of reality. From a single spark came everything: galaxies, stars, planets, and life itself. And while we may never know everything, the journey of discovery continues, with telescopes reaching deeper into space, and minds reaching deeper into time. The universe is still expanding, still unfolding, still telling its story, and as long as we keep asking questions, we'll always be part of that story. If you enjoyed this journey through space and time, don't forget to like, subscribe, and share this video with fellow explorers. Leave your thoughts or questions in the comments, because every question is a step closer to understanding the cosmos. Until next time, keep looking up, because the story of the universe is also the story of you.